Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video, we are going to see about resistors, which are the most important basic component of analog electronic circuits. A resistor is a component that opposes the flow of current. Its symbol is R and it is measured in ohms. In a simple circuit containing a battery and a bulb, the battery causes current to flow through the bulb and the bulb has internal resistance that limits the flow of current. In any resistor, electrical energy is transferred to heat. So below figures represents the symbols used for representing a resistor. So the first symbol represents a fixed resistor which has a fixed value, and the variable resistor, it produces a range of values. By adjusting the knob, we can choose variable resistance values. And the third picture represents a practical resistor. So next we will see how to find a value of resistance. So just consider the resistor consists of 4 bands, and the first band represents the value, the second band represents the value, and the third band represents the multiplicand. So for example, if we are having green, red and blue colors in a resistor, then the green represents the first value of represents, which means just look at the table here. For green, we are having the value as 5. So the first digit that is used to represent resistance is 5. And here the second stripe of band is red in color. And for red, we are having the value as 2. So by combining green and red, we can come to know that the value of this resistance is 52 from the first 2 bands. Now come to the band 3, which is blue in color, and the value corresponds to blue is 6. And it is represented as 10 power 6. So the third band is represented as 10 powers. So the value of this given figure is 2, that is 52 into 10 power 6. And the last band represents tolerance. So every resistor is having a change in value. That tolerance is represented by the stripe. So commonly there are 2 stripes used, gold and silver. So gold has the tolerance of plus or minus 5% and silver has the tolerance of plus or minus 10%. And this table represents various values that are used to represent by colors. So next we are going to see the equivalent resistance when the resistors are connected in series. So let us consider 3 resistors R1, R2 and R3 which are connected in series across a voltage source V. When these resistors are connected in series, they have its own internal drop voltages represented as V1, V2 and V3. And note that current through the series resistance is same, and which is represented commonly as I. So now according to Kirchhoff's voltage law, we can write that the supply voltage V is equal to the drop voltages V1 plus V2 plus V3. So we know that V is equal to IR from Ohm's law, so that V is replaced by IR1 and V2 is replaced by IR2 and V3 is replaced by IR3. Now from this equation we can calculate I as I is equal to V by R1 plus R2 plus R3. And we know that the total current through the circuit I is equal to V by the total resistance Rs. So if we equate these 2 equations, V and V get cancelled. So remaining we are having Rs is equal to R1 plus R2 plus R3. So here we can come to the conclusion that when resistors are connected in series, the total resistance of this series is equal to addition of all the resistances. So if we take the total, because we know that all these voltages V1, V2, V3 are is equal to V. So if we cut all V equations, then we can get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that is the equivalent resistance of parallel combination. So now let us look into an example. Let us consider three resistors are connected in parallel as shown in the figure. The resistor values are R1 equal to 20 ohm, R2 equal to 30 ohm and R3 equal to 40 ohm. And what is the total equivalent resistance? So we know that for parallel combination, we know that R equivalent is equal to reciprocal of 1 by R1 plus 1 by R2 plus 1 by R3. So when we substitute all these values in this equation, we get the R equivalent value was 9.23 ohm. Thank you.